Hello guys, let's solve another Leetcode problem from line 75 list. The next problem will solve product of array except self. This problem is Leetcode 238. And the problem is given an integer array, nums, return an array answer such that answer I is equal to the product of all the elements of nums except nums I. So basically, if we are given all the numbers in an integer array like 1, 2, 3, 4, our output would be the first location would be the multiplication of all the numbers except these one. So if we multiply 2, 3, and 4, you'll get 24. Same as for 2, we want to find out the multiplication of all the numbers except these two. And if you multiply 1, 2, 3, and 4, that's become 12. So second location is 12. And for the next location, 3, we want to multiply all the numbers except 3. So 1, 2, and 4. So that becomes 8. There is a very easy way to solve this problem. So you want to clarify with the interviewer first. Because what you can do, you can basically multiply all the numbers first and then divide off all the specific positions. So if you multiply all the numbers like 4, 3, and 2, that becomes 24. Now for each of the position, you just divide 24 divided by 1, that becomes 24, 24 divided by 2, that becomes 12. That one way to solve the problem. But if you read the question description, it said that actually you cannot use any division operator. So that's the catch here. So you can't use division operators. And second thing, you want to write an algorithm with order n. That means there is an easy way to solve with order n squared. What does that mean? That means for each of the numbers 1, you can basically going through another nested for loop where you basically go through multiply all the numbers, right? And for 2, same, going through the same loop. So that will become order n squared. So if you want to make it better, then we need to think about what are the other ways you can improvise, right? So if you use a nested for loop order n square, most likely the space complexity would be order of n. If you want to make it better, that means we need to store some of the values. So let's talk about what are the things we can store so that we can get the results quickly. One idea to keep in mind that actually for each of the elements, for example, if let's talk about 3, right? So for 3, you want to multiply all the numbers except 3. So there is a multiplication of 1 and 2 in the left side and 4 in the right side. And for final result, you basically want to multiply the left and right product array. Same as for 2, if you can store for these 2, if you can save the left side multiplication table and also the right side multiplication table, then you can just return that too. Based on that idea, we can go ahead and implement it. So we need a couple of things. We need actually an array which will store all the values in the left side, product of left side. And we need another array which will actually store on the right side. And we will go into the improvement phase later. So for our case, if you think about if there is no numbers, so if your nums is none, you can just return none. Let's get length of this array. So our length of this array is n. What we want to do, we need a left array, which you can, and also right array. And for all of them, we want all the values with 1. So after this line, you will have the left and right with all the 1, and the size would be n. So let's talk about what we want to do. So at first, what we want to do, we want to find the multiplication of all the values until that point, right? So your current product start with 1 and your for loop x in range. For left indices, we will start with 1 and go until n. So why we are not updating 0? Because the first number would be always 1. Because for then what you want to do, current prod multiplication with the numbers what you have already here, idx minus 1. And then what you want to do for each of the values, you want to update the value in the left index. So basically, if you print out left here, you will be able to see there are a few things. So the first element start with 1. Second location 2. For 2, we basically multiplied 1 with the current product multiplied with the first value, idx minus 1. And idx minus 1, we have 1. So we will get the second value is 1 as well. And for next location, you multiply it by 2, so it becomes 2. And then you get 2 multiplied by 3, that will becomes, and you get 6. So this is your left array. Same way we can actually do the right side. For right array, and the idea is that you start with the right side and come back from the left. So start with the -2 location and you'll come back from right to left for each of the values. And we will have the same thing multiplied by nums of idx plus 1. Basically, right idx will be your current product. And here, if you print the right, you'll be able to see your, so you start with the right side. So rightmost value would be 1. And next value would be 1 multiplied by 4. And the left side value of this one, 4 multiplied by 3, that is 12. And for next one, 12 multiplied by 4, that is 24. So as you can see, for our given input 1, 2, 3, 4, our left array include 1, 2, 1, 1, 2, 6, and the right array include 24, 12, 4, and 1. And final result, what you will have basically for each of the values, you multiplied these specific two values, left I and right I. So you get 24 and then 12, and then 2 multiplied by 4, 8, and then 6 multiplied by 1, that's 1. So basically, if you want to return result array, that would be 1 multiplied by same as 1 actually. For each of the value range of n, you basically update multiplied by left index by right index. And then you can return the results. So we are going through the loop only once here in the left, so order n. This is also order n. And then you're going through this loop again, so order n again. So basically order of 3n, which is a linear time. Space complexity, you are storing the results left and right array. So basically order of n and order of n, so order of 2n. So if you think about the runtime complexity, which would be order of 3n and the space complexity order of 2n. So basically a linear time algorithm with linear space. Let's run this one. Too many values to unpack. So let's see, what did we miss? So we miss one more thing here. Okay, so looks good to me. So let's hit the submit, and then we'll come back to fix this one again. Okay, so that's accepted. Let's go back to the question again. And you see the next part of this question is, can you solve this problem in order n extra space complexity? So the main idea is that we used order n space complexity, or a runtime algorithm is still order n, but the space complexity we use order n. So, and the another hint is that output array does not count as a space for space complexity analysis. So what they are saying that actually the result array, what we are still using, that we can use, that's not in space complexity more than order n. So you can continue to use that result, but can you solve this problem without these extra two left and right? So to solve this problem using only order n, that means next question is that do we need this left and right side array, right? So can we get rid of this one and still find that result? The thing we can do that actually, you can see your final result IDX, which is actually multiplication of left and right. So if we start this problem with result, just copy this line and start it here. And if we can replace all the values, whatever we are calculating in the left side with the result, then we will have the intermediate result. So basically what we are doing, we are commenting out this left and right. We don't need the left. For all the things we have done in the left, we will put it into the result array automatically. So after this part, basically our result array contains all the value of the left. So basically 1, 1, 2, 6. Now let's talk about what we are doing in the right side. In the right side, we are calculating the value and putting in the right side. But these value right IDX, we are still using in the second for loop here inside right IDX multiplied by left IDX. So we can do the same thing here, whatever we are doing there. We'll copy this line, paste it to here. So we'll do the same thing. The only difference is that our left becomes right now the result. And you see our right IDX, which didn't change from car prod, right? So you can basically replace this right IDX to the current product. So you can get rid of these one too. And now you can make it a little bit fancy with this guy, and then you can comment out this as well. So what did we remove? We remove all the reference of left and right. After the first loop, we have all the answer in the left array to the result array. And after the second loop, this for loop, we basically have the right array results, which is actually in the current product, which we will basically multiply it and put in the result. And finally, we are returning results. And if it worked, then we will get rid of all the comment and then make it a little bit cleaner and then submit it. So basically, you can get rid of this guy, get rid of this right guy, and you don't need this guy as well. So that's the cleaner implementation. You can see actually we the only extra variable we will use the current product, as always starting with 1, and our previous result in an array of n element, which basically doesn't count with the extra space. So you can hit submit. If it works, then actually we are good here. So yep, that's the implementation of order n extra space and linear time complexity. This one is an interesting problem because it comes down to a linear time problem with constant space. And you need to think about what are the ways you can improvise based on the space and time complexity. That's all for this video. Thanks for watching. We will go into the next problem in the next video. Thanks for watching.